Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about the construction of the isometric projections of a solid when the orthographic views of the solid they have been provided to us. So here we have the front view, the top view and the right hand side view of the given solid. And from the three projections, that is the front, top and the side view, we need to work out the dimensions of the front face of the solid, top face of the solid and the side face of the solid. The reason is because all these three faces of the solid, they will be apparently visible onto three planes of the isometric projection, because the isometric projections are the 3D projections. So in the 3D projections we are going to have the front view, side view and the top view of the solid visible in a single plane. Now in this isometric projections we require the dimensions of the front face, top face and the side face. So let us evaluate these dimensions from the orthographic projection. So here we have the orthographic projections with us. So the length of the solid is given to us as 90 millimeter. So in the front view this length will be appearing as 90 millimeter, and front view also depicts the height of the solid. So the height of the solid is available to us from the side view, which is equal to 60 millimeter. So it means that the front view rectangle that we have to draw onto the isometric projections should be having the size 90 millimeter by 60 millimeter, right? So this is the size of the front face. Similarly, the top face of the solid, it should have the dimensions. Please check. The length has to be equal to 90 millimeter. So this is the same length as that available in the front view, and the width is available to us as 60 millimeter. So this is 60 millimeter by 90 millimeter, right? So 90 millimeter happens to be the length and 60 millimeter happens to be the width. So this is the size of the top face of the solid. Similarly, the side face, in the side face the width of the solid, so the width of the solid is available to us in the top view. So this is the 60 millimeter width. So this width will be available with us in the side view. And the height of the solid, so this was available even in the front view. This is equal to 60. So this is 60, that is the height. This distance is also 60, that is the width. So the side face of the solid should be drawn with the dimension 60 millimeter by 60 millimeter. So let us see that where do we draw these three dimensions into the isometric projection view. So in the isometric projection view, here we have the x-axis, here we have the z-axis and here we have the y-axis. So y-axis will be representing the height of the solid. So this dimension should be equal to the height of the solid, which is equal to 60 millimeter. Now we have been provided with the right side view of the solid, which has been drawn on the left side of the front view. So since we are going to look at the solid from the right hand side, so that is why the right hand side projections of the solid have been obtained in the orthographic views. So here this right side view will be obtained when we have the right side face of the solid located along this y and z plane over here. The y plane will be giving us the height of the solid and the z plane or the z axis will be giving us the width of the solid. So this width and height, which is equal to 60 millimeter each, so this is going to give us the construction of the square side face corresponding to this solid. Similarly, if this is the side view, so this will be our front view. So in the front view we have the length. So length is equal to 90 millimeter. So this is the 90 millimeter length of the solid, which is viewed in the front view of the orthographic projections. Now this is the height. So height we have already obtained from the side view projection. Now two more isometric lines we are going to draw parallel to the x-axis and the y-axis, so that this rectangular surface which is going to represent the front view of this particular solid will be represented over here. Then last we have the top face. So top face, since the solid is resting on the ground, so it will be represented by x and z plane. So on the x plane we have already marked 90 millimeter length. On the z plane we have already marked 60 millimeter length. So we will be again drawing two isometric lines, one parallel to the z-axis equal to 60 millimeter, another one parallel to the x-axis which will be equal to 90 millimeter. So this will give us the top face projections over there. So these are the projections of the base. Similarly, the rectangular projections at the top will also be the same, right? So once we know that this is the projection face for the side view, this is the projection face for the front view, this is the projection face for the height, right? So this way we'll be able to draw all these projections onto the isometric plane. Now in order to draw the isometric projections, the first thing, whatever you see true lengths they are available over here, whatever true lengths they are available from the orthographic views, we have to transfer all these true lengths onto the true scale, and the corresponding isometric lengths needs to be evaluated. So once we evaluate all the isometric lengths corresponding to the true lengths which are available in the orthographic projections, only then the isometric projections they can be drawn. Next is that once we have got this particular solid, so once again as usual we are required to divide this solid into multiple elements, so that the breakdown of this particular solid into smaller constituent elements, they will facilitate easy construction of this particular solid into the isometric projection. So we have to divide this solid into multiple smaller elements. So please check my first multiple element over here. First element out of many, it is this particular ring. That is, there is a bottom block which I can observe over here. This is the bottom block of this particular solid, which is nothing but it is a rectangular component. So I can see even from the front view, in this block, this is the flatter portion of the block. Please check, this is the flatter portion of the block, and then there is this vertical portion of the block. So in this first element is, I will be drawing one ring which will be at a distance of 20 millimeter. So this will be defining my first element or the base element of this solid. So this is going to be my first element. Then in the second element, please check, I am going to have one flat surface over here. So this height of the first element is 20 millimeter. So the total height of the solid happens to be 60 millimeter. So out of this 60 millimeter, I have got three segments. First segment is 20 millimeter corresponding to the bottom element. You see, this is my bottom element of the solid. Then the second element of the solid is this flat segment over here. So this is a flat rectangular segment. Please check. The total length of the solid happens to be how much? 90. Out of this 90, I have got 30 millimeter over here. So 30 millimeter, it is the length of this flat segment which will be joining with the base element over here, right? So this is my flat segment which will be joining with the base. So I can connect my base element with this vertical component. This is going to be my vertical component. Now once I have got this vertical component which will be the flatter component, now I need to look into the second element. My second element, you can check, this is my flat face. So this flat face corresponds to this rectangle. Please check this out. This corresponds to this second segment where I am able to view the true shape of this flat segment in the front view. So the true shape of this flat segment is visible to me in the front view. Whereas my third element, The third element is the slanting shape over there. This is a slanting surface. Please check. This is my slanting surface and this is going to extend 30 millimeter. How did I work out this is 30? Because the total length is 60. 60 I have obtained from here. The total length is 60. This is 30 and this is also 30. So this 30, it is corresponding to this inclined segment over here. Please see. This inclined segment, it is going to give me this rectangle from the top view. So in the top view, this is the apparent shape of this surface. So apparent shape, why this is apparent shape? Because this happens to be an inclined surface. If I am looking at this surface from the top, so the projection of this inclined surface in the top view will be giving me this particular rectangular shape. So even though it may appear to be a simple rectangle, but this rectangle has been obtained corresponding to this inclined surface over here. So this is the inclined surface. So what are the dimensions of this inclined surface? We can check. The length of this surface is 30 millimeter and this is the hypotenuse basically, right? And what is the depth of this particular inclined segment? This is equal to 20 millimeter. How did I evaluate this 20? Because the base ring is 20, intermediate flat portion is also 20, this intermediate flat portion, and then this is the slant portion. So if I work out this length, so this distance is 30, this distance is 20, so this will automatically be hypotenuse of this particular right angle triangle. Based upon construction, we are going to work it out. Okay, so now first segment, it is a flat segment that we will be drawing. Then the second segment is, this is the vertical surface which is visible in the front view over. So this is the true shape of this surface which we are able to see. And the dimensions of this surface, total length is 90. The length of this surface is 30. You can check this one. So the remaining surface length is 60 millimeter over here. So this surface will be 60 millimeter long, right? So with this we can see over here. This is 60 millimeter long. So from the top, it will appear to be a rectangle. So this rectangle, it is apparent shape in the top view. Even if we are looking from the front, this rectangle is again the apparent shape. This is again the apparent shape in the front view. Whereas if we look at this particular surface from the top view, so this surface which we have obtained over here, this will be the apparent shape, and this surface which we are obtaining, what is this surface? This is the surface which is corresponding to element number 1, corresponding to which the first ring we are going to draw over there. So this surface will be 30 millimeter by 60 millimeter. So this is this 30 millimeter which is appearing over here, and it is this 60 millimeter length which is appearing at this particular juncture. So this way, so we have obtained the breakdown of 3 elements over here. Now we are going to project these 3 elements into the isometric projection. So once again, we have got the horizontal datum line drawn over here. From this horizontal datum line, we have marked a point, and then from this point, we are going to move towards the left side so that the isometric x-axis has been drawn at an angle of 30 degrees. Similarly, from this point again we are moving towards the right so that the isometric axis, z-axis, has been drawn again inclined at an angle of 30 degree. Now onto this isometric axis, that is x-axis, the length of the solid will be drawn because this will be our front face, and onto the z-axis, the width is equal to 60 millimeter. So this width of 60 millimeter will be drawn, and along the y-axis, the height of the solid, that is 60 millimeter length, will be drawn over there. So this will be 60, this will be 60, so that this will become a square over here. The side face, it will become a square, and this particular solid which we are going to draw, this will become a square prism, and the length of this prism will be 90 millimeters because the front view edge length is equal to 90 millimeter, right? So we have drawn this 90 millimeter, and the height of the front face is equal to 60 degree. And once we draw an isometric length parallel to the x-axis. So this is going to lead to the completion of the front face of this particular solid. So the front face will measure 90 millimeter by 60 millimeter. Now having completed the front face construction, now we move on to the construction of the side face of this particular solid. So the side face, we have already discussed that the width of the side face will be equal to 60 millimeter, right? So the width of the side face of the solid is 60 millimeter, and the height of the solid we have already obtained in the front view. This is also equal to 60 millimeter. So since the height of the side face is also 60, the width of the side face is also 60, so we have been able to obtain a square side face over here, right? So this is our right side view. So the right side view projection plane will be this one over here, right? So this is the face which is going to contain the details regarding the side view of this particular object. Now let us complete the top view. So in order to complete the top view, we have to draw two edges over here. First edge, this edge will be equal to 60 millimeter length, and this will be parallel to the z-axis. Similarly, the another isometric edge we have drawn, it is this edge, and this edge is again parallel to the x-axis, and this edge measures 90 millimeter. So this face is basically the bottom face of this particular solid, and this is going to give us the details of the top face, because the top face will also be similar. Let us complete the top face. So in the top face, once again, we have drawn one isometric edge which is parallel to z-axis, and another isometric edge has been drawn which is parallel to the x-axis, and this edge again measures 90 millimeter. So this is the top rectangular face, and this one, it is the bottom rectangular face over here, right? So this face dimensions, they are equal to 90 millimeter by 60 millimeter. So here we have the front face which is measuring 90 millimeter by 60 millimeter, the top face which is also measuring 90 millimeter by 60 millimeter, and a side face which is measuring 60 millimeter by 60 millimeter. So all the three faces, they have been drawn over here. Now we have to draw the construction of the details regarding the element number 1. So we had discussed that this is our element number 1, right? So this is corresponding to the bottom portion of the solid. So you always, we have to start with construction of the solid from the base, right? So the bottommost portion, it is this one. And what are the characteristics of this element? So this element is having the characteristic that the length of this element is equal to 90 millimeter, height of this element, it is equal to 20 millimeter, and the width of this element happens to be 60 millimeter. So we are going to draw a ring over here which is going to define the bottommost element. This is the bottom block, element number 1, and we can check the height of this element corresponding to the base over here, right? So this is the first element that we have picked up from the orthographic projections. Now corresponding to this element, we have got the length is equal to 90 millimeter, width is equal to 60 millimeter, and the height, it is equal to 20 millimeter. Now please check this inclined segment, it is going to rest over this flat segment over here. So this is going to be a flat segment which will be located at a distance of 30 millimeter from this corner. It is this corner as well as this corner. So these are the two corners from which our slant portion is going to start with. But this segment is going to be, length of this slant segment will be 60 millimeter. That is, this portion 30 millimeter, it is a flat portion. So first of all, I have to draw the construction of this flat portion also. So in order to draw this flat portion, please check, my flat portion happens to be this one. so that in the top view, that is this top portion is a horizontal surface over there, so that once I draw this projection line, which will be at a distance of 30 millimeter from the leftmost edge of this particular solid. You see, this is my left face, and from the leftmost top corner, it is this one. If I draw a projection line which is parallel to this edge, so this is going to define my top face of this particular element, because this element is going to be joining with the element number 1. So we have constructed this particular vertical face and this horizontal face over here alongside element number 1. Why? Because you can see over here in the front view, I am able to obtain this L shape over here. So now I am going to carry out the breakdown of this total element. That is, this total element is this one. That is, at the bottom 60 millimeter it goes straight. So 60 millimeter it will be going straight. Whereas for the remaining 30 millimeter, this is my remaining 30 millimeter. So for the remaining 30 millimeter, I am going to have the top face, which will be a straight parallel surface, and from the front side, so this parallel surface, it will be moving down as a flat line, so that this L construction I will be obtaining. Okay, so now this is the horizontal segment corresponding to this 30 millimeter width over here. This is the horizontal segment of the top, and this is the vertical segment which is starting from the top and it is moving 40 millimeter down, so that it is going to coincide with this ring which I have created, which is at a height of 20 millimeter. So I have started with drawing this horizontal portion corresponding to this top face. So this becomes my top face over there, and once it drops down, so we move 40 millimeter from the top. So this way, this construction is corresponding to this portion of my orthographic projections, and this rectangular construction 40 millimeter is the depth and 30 millimeter is the width over there. So this is the 30 millimeter and this is 40 millimeter, right? So this way, this segment has also been created and this has been clubbed with element number 1. So reason behind clubbing I have explained, because in the front view there is a single view for this particular L shape. So that is why this L shape has been obtained even in the front view, and here you have this flat rectangular surface. So the construction of this flat rectangular surface has been completed alongside element number 1. Now we move on to element number 2. So please check element number 2. You see, you have got two things over there. One is this slant surface, and then there is a flat vertical surface. So these are the two surfaces which we need to draw. So in order to draw this flat surface, we need to obtain the position that where this slant surface is going to end. So I will be starting with the construction of the flat portion first, and then this slant portion first of all, and then I will be moving on to the construction of this flat vertical portion over there. Now let us start with the construction of this slant portion. So please check, the slant portion is starting from this rear corner. So rear corner is this one. So this is my rear corner and this is my rear corner, so that the length of the slant portion should be how much? It is equal to 60 millimeter. So this was 30, so this is 60 millimeter, right? So here I have got 60 millimeter as the length of this slant portion. And another thing, I know that this slant portion will be ending at a distance of 20 millimeter above this first ring which I had created. So this was the first ring corresponding to the thickness of the element number 1. Now corresponding to this element number 2, I know the height of element number 2. So what I will be doing, I have marked the height of the element number 2, which is from the bottom basically. So 20 millimeter was the height of the first element, 20 millimeter it is the height of the second element, which happens to be a rectangular surface. Please check. This is a rectangular surface over here which appears as a true shape rectangle in the front view, and it appears as an edge view, vertical edge view in the side view over there. Now, in order to obtain this point, I have to draw this flat surface. So in order to draw this flat surface, a second ring has been created at a height of 20 millimeter above the first ring. So please check, this is my second ring or the locus lines which I have created. Now this ring will facilitate the location of this point of the slant surface. So how this point of the slant surface can be located? I am going to move from this rear point, right? So I am going to move from this rear point, that is top corner. So I'll be moving from the top corner, that is this corner and this corner, and then I will be moving along this ring, second ring, which is drawn at a distance of 40 millimeter from the base, 30 millimeter towards the front end of this particular solid. So this total width happens to be 60 millimeter. I'll be moving forward from the rear end towards the front end at a distance of 30 millimeter, that is the midpoint. So once I obtain this distance, then this slant edge can be generated over here. So this slant edge we draw, this slant edge we draw, and once we join, so this surface will be generated over here. So let us do it. This is my 30 millimeter. You see, distance from the rear vertical face. 30 millimeter is the distance from the rear vertical face. Now my surface is going to start from this corner. It is this corner. It is going to end up at this point, and this point is 40 millimeter from the base and 30 millimeter in front of the rear vertical edge. So this is my rear vertical edge over here, right? So from the rear vertical edge, I will be moving 30 millimeter towards the front edge, and then 20 millimeter below the top edge, or 40 millimeter from the ground. So this is my 40 millimeter from the ground or 20 millimeter from the top. So from this point, now you can check, from this point I have drawn this horizontal line measuring 30 millimeter. So this gives me the point of intersection of this slant edge with the ring which is drawn at a height of 40 millimeter. So this gives me the edge of the slant surface. Similarly, from this side, what I have to do? I have to draw first of all an inclined surface which will be parallel to this one. Please check. An inclined surface has been drawn which is parallel to this edge over here. And again, this distance will automatically be 30 millimeter from the rear end, and the height, this will be 20 millimeter. So here you see what I have done. I have drawn this surface equal to the same length and at the same inclination, right? So this length and angle of inclination and this length and angle of inclination remain same. Now once I join this point with this point, so I am going to get the shape of this particular inclined surface. You can see over here, this is the shape of the inclined surface which I have been able to obtain. And having obtained this edge, now I have drawn 20 millimeter down, that is corresponding to the flat surface, this one. Now my third element I have started with. This is my third element. So I am going to draw vertical projection equal to 20 millimeter. So from this surface 20 millimeter down, you can see it is meeting at this particular ring which is at a distance of 20 millimeter from the base. And once you join this face, so this is my vertical face. This is my vertical face which is visible to me in the front view. So this vertical face has also been generated. Now this face has been generated as I am looking from the front. So you can see this is a longer surface over here which appears to me as a shorter surface. That is why I told you that this surface which is appearing in the front view corresponding to this larger inclined surface. So this is going to be an apparent length. Similarly, this surface which is the top view of, you can see this is a bigger surface over here. So this is a bigger surface, but this is inclined. So the length of the surface is more, but over here it is appearing to us as a shorter surface over there. And the remaining surface you can check corresponding to element number 1, it is this one. So corresponding to this surface, this is 30 millimeter and this is 60 millimeter. So 30 by 60 millimeter, this surface appears as a true length in the top view projections over here. So please check, this is the top view projection. So this surface corresponding to element number 1, it is true shape. This surface corresponding to, once again, element number 1, this is also appearing as a true shape. So these two surfaces, they are true shapes. This one is the apparent shape. Similarly, from the side view, if you are looking at it from side, we can see this is the inclined surface. We have obtained the inclined. This was the vertical surface. We have obtained the vertical surface. And then this is the element 1, right? So this is the remaining portion of the element 1. So you can check, this is the remaining portion of the element 1. And since again there is no line over here, so we are going to join this line and this line and this line dark over here. So all the elements, they have been obtained. You can check element 1 corresponding to the bottommost ring, element 2 corresponding to this vertical face which we have been able to generate corresponding to these two surfaces, and element 3 which is the inclined surface at the top. So this element 3 surface has also been generated over here. So this way the construction of the isometric projections is complete. Now we are going to show which of these edges they will be visible and which of the edges they are not visible. So please check, this is my top surface. So this has been represented as the true length or true shape into this top face over there. So this we have discussed. So this is the edge corresponding to the apparent shape of the inclined surface, and in the front, please check, this is the L shape which I have been able to obtain. So that is why we clubbed this construction along with the element 1, right? We clubbed this construction along with the element 1 over here. So this portion is appearing as a true shape once again. So this is also true shape, this is also true shape, and this is the apparent length over here, apparent shape. This surface represents apparent shape because you are looking at this surface, inclined surface, from the front side. Okay, so now we have joined this, and then this is my inclined surface. Okay, so it is this biggest surface which appears as a very short, you see, surface over here. This appears to me as 20 millimeter by 60 millimeter. So this 60 is okay, no issue with this 60. Issue is with this inclination over here. So since the angle of inclination of this surface with the VP is higher, so that is why the reduction is obtained higher on the VP, whereas on the HP the angle of inclination is less, so slightly better projections they have been obtained onto the horizontal plane. So angle of inclination with HP, you can see this angle is around 25 degree, whereas this angle is around 65 degree. So angle of inclination with VP is more. That is why higher reduction on the vertical plane has been obtained. Now we have to draw this flat surface. Please check, this is a flat surface which was appearing over here and also appearing over here. And then this is the flat, you see, bottom element which we have to join. So this edge and this edge has to be joined alongside this edge, right? So this edge and then this edge will be joined. So this way we have been able to obtain the isometric projections using the orthographic view dimensions over here, and this we have been able to draw through division of this particular solid into some smaller elements over there. So once we are able to identify the smaller elements, so we are able to work out the isometric projections in a more appropriate manner, right? So this is all for today. So we are going to continue with further discussion regarding few more cases on the isometric projections in the coming lectures. So thank you very much. Thanks a lot.